Hi, and welcome to this Now Maths Revise Now video on writing recurring decimals as fractions. This video would be perfect for you if you're wanting a quick recap of 4 questions you may be asked to answer on this topic. If you're only just getting started out with this topic, you might want to watch our in-depth video linked below. Now let's get started. So for our first question, we're asked to use algebra to show that 0.2 recurring can be written as 2/9. This is a fact that you might already be familiar with, but we're asked to use algebra to show this. So there's a very specific method we have to use. So to use algebra, we're going to start off by calling 0.2 recurring x. So we write down that we're going to let x equal 0.2 recurring. And you might choose to write this as x equals 0.222, just so you can get a feel for what the decimal looks like. Now to turn this into a fraction, we need to try and eliminate the decimal. So we multiply by 10. So x multiplied by 10 is 10x. And 0.2 recurring multiplied by 10, all of the digits shift to the left one place, so we get 2.2 recurring. Now if we subtract these two decimals from each other, the recurring part will cancel, so we'll be left with an integer or a whole number. So we're going to do exactly that. I'm going to set this up as a subtraction. So we're going to do 10x first because that's the larger, which we said was 2.2 recurring. Subtract x, which we said was 0.2 recurring. And then 10x subtract x is 9x. And if we subtract the decimals, we can see that the 0.2 recurring part will completely cancel, and 2 subtract 0 is 2. So we have 9x equals 2. This is an equation that we can now solve, and if we know 9x, to work out x, we divide by 9. So on the left we have x, and on the right, 2 divided by 9 we can write as 2 over 9. Since we started off by saying that x equals 0.2 recurring and we've now ended up with x equals 2/9, that proves that 0.2 recurring must equal 2/9. So we have shown what the question asked us to show. Now looking at a slightly more tricky question. This time we're asked to use an algebraic method to write 0.45 recurring as a fraction in its simplest form. So to use algebra, we start off in the exact same manner and we let x equal 0.45 recurring. Since we have a dot above both the 4 and the 5, that means that those two digits repeat infinitely. So we would have a decimal that looks like 0.45, 45, 45, and so on. Now we want to try and eliminate the decimal like last time. So let's try multiplying by 10 again. X multiplied by 10 is 10x. And multiplying the decimal by 10, everything shifts over to the left. So we end up with 4.5454 and so on. Now this time, if we take a look at these two decimals, if we were to subtract one from the other, the recurring part wouldn't cancel because the decimals don't look completely identical after the point. When this happens, we multiply by 10 again and again until we find something that does. So multiplying 10x by 10 would give us 100x. And then multiplying our new decimal by 10 shifts over to the left one place again. So we get 45.4545 and so on. Now if we take a look at what we have, we do actually have two decimals which match completely after the decimal point. So our first decimal was 0.45 recurring and our last decimal ends in 0.45 recurring. So if we subtract one from the other, the decimal part will cancel. So let's do that. So we write down the larger one first, so 100x, which is 45.45 recurring. And we are subtracting x, which is 0.45 recurring. And then subtracting x from 100x gives us 99x. And when we go to subtract the decimals, the recurring part will cancel, and 45 subtract 0 is 45. We're then left with an equation of 99x equals 45. So to solve for x, we divide by 99, leaving us with x on the left, and 45 divided by 99 we can write as 45 over 99. And since we started out by saying that x equals 0.45 recurring, and we've ended with x equals 45 over 99, that tells us that 0.45 recurring is equal to 45 over 99. And one slight difference with this question is we are asked to write the fraction in its simplest form. So let's just check if 45 99ths will simplify. I can see that 9 is a common factor of both 45 and 99. So let's divide the numerator and denominator by 9. And when we divide 45 by 9, we get 5. And 99 divided by 9 is 11. And since 5 and 11 are both prime numbers, we can't simplify this any further, so our fraction in its simplest form is 5/11. Now let's try another similar question. So for this question, we're asked to use an algebraic method to write 0.73 recurring as a fully simplified fraction. Given that we're using an algebraic method again, we're going to write let x equal 0.73 recurring. And if we were to write this out a little more fully, given that the dot is only above the 3, this would be 0.7333 and so on. We're then going to try and eliminate the decimal as we did before. So we're going to multiply by 10 first. So x multiplied by 10 is 10x. And multiplying the decimal by 10, everything shifts to the left once, so we end up with 7.3 recurring. Now if we were to try and subtract one of these decimals from the other, we would still end up with a decimal answer, given that these decimals do not completely match after the point. When this happens, we multiply by 10 until we find two decimals which do match. So multiplying 10x by 10 gives us 100x. And then multiplying the decimal by 10 shifts all the digits over to the left by one place to give us 73.3 recurring. Now if we take a look again, we can see that we do have two decimals which match perfectly after the point. We have our 100x, which starts with 0.3 recurring, and 10x, which also starts with 0.3 recurring. So these are the two decimals that we're going to subtract. So we write down 100x first because that's larger, which is 73.3 recurring. And we subtract 10x, which is 7.3 recurring. And 100x subtract 10x is 90x. Then when we subtract the decimals, we can see that the recurring part will cancel. And we are left with 73 subtract 7, which is 66. We're now left with the equation 90x equals 66. So we solve by dividing by 90. And we get x on the left. And 66 divided by 90 we can write as 66 over 90. And since we started by saying that x equals 0.73 recurring, and we've ended up with x equals 66 over 90, that means that we can finish off by saying that 0.73 recurring must equal 66 over 90. And similar to the previous question, we're asked to write 0.73 recurring as a fully simplified fraction. So let's check if we can simplify 66 over 90. So 66 and 90 both have a common factor of 3. So let's divide the numerator and denominator by 3. Dividing the numerator by 3, 66 divided by 3 is 22, and 90 divided by 3 is 30. 22 and 30 are both even numbers, so they are definitely divisible by 2. So let's divide the numerator and denominator by 2. And 22 divided by 2 is 11. 30 divided by 2 is 15. And 11 and 15 share no common factors, so our final answer is 11/15. Now for our final question in this video, we're asked to prove using algebra that if we add the two recurring decimals together, we get an answer of 5/6. Now to prove that this is true, we're going to assume that we don't know the answer is 5/6. We're going to add the two recurring decimals together, and we're going to show that whatever we get as the answer is 5/6. We're asked to use algebra, so the easiest way for us to add these two recurring decimals together using algebra is to convert them both to fractions. So let's start with 0.38 recurring. If we're going to convert this to a fraction, we start off by letting x equal 0.38 recurring. And if we were to write this out a little more fully, we could write this as x equals 0.3888 and so on. We then multiply by 10. X multiplied by 10 is 10x. And multiplying the decimal by 10, everything shifts to the left, so we end up with 3.8 recurring. Neither of these decimals match completely after the decimal point, so we multiply by 10 again. So 10x multiplied by 10 is 100x. And 3.8 recurring multiplied by 10 is 38.8 recurring, since all the digits shift to the left. Now we do have two decimals which match perfectly after the point. So we have 10x, which begins with 0.8 recurring, and 100x, which begins with 0.8 recurring. So we subtract 10x from 100x. So starting off with 100x subtract 10x is 90x. And then 38.8 recurring subtract 3.8 recurring, we can see that the recurring part will cancel, and then we're left with 38 subtract 3, which is 35. We now have an equation that we can solve by dividing by 90, and when we divide by 90, we get that x equals 35/90. Now we've converted 0.38 recurring into a fraction, we need to do the exact same for 0.4 recurring. And remember, even if you know what either of these are as a fraction, given that we're asked to use algebra, we must show our method. So this time I'm going to write that we're going to let y equal 0.4 recurring. And the only reason I've chosen to use y instead of x is because we've already used x in this question. We can then write this more fully as 0.444 and so on. We then multiply by 10, so y multiplied by 10 is 10y. And 0.4 recurring multiplied by 10 is 4.4 recurring, because all the digits shift to the left. Straight away, we have two decimals which are identical after the point. Both of these decimals begin with 0.4 recurring. So our subtraction this time will be 10y subtract y. And 10y subtract y is 9y. And then subtracting the decimals, the recurring part will cancel, and 4 subtract 0 is 4. We're left with our equation of 9y equals 4, so we solve by dividing by 9 to give us that y equals 4/9. So we've converted both of our recurring decimals into fractions. Now let's try and use this information to answer the original question. So we started off wanting to know the answer to 0.38 recurring add 0.4 recurring. We've now written each of these as a fraction, so we know that 0.38 recurring we can write as 35/90ths. And we know that 0.4 recurring we can write as 4/9. So instead of adding together the two decimals, we're going to add together the two fractions. To add together two fractions, we need a common denominator. So 9 and 90 both go into 90, so let's try and get a common denominator of 90. If we're going to use 90 as our common denominator, the first fraction is okay as it is. The second fraction of 4/9, we're going to need to multiply 9 by 10 to make this fraction in 90ths, which means we also need to multiply the 4 by 10. So 4/9 is equivalent to 40/90ths. Now that both fractions are in 90ths, we're going to add them together. So 35 add 40 is 75. And so when we add the fractions together, we get 75/90ths. The question asked us to prove that if we add 0.38 recurring to 0.4 recurring, we get an answer of 5/6. So let's see if we can simplify our answer of 75/90ths. I can see that both of these numbers are divisible by 15. So let's divide numerator and denominator by 15. And 75 divided by 15 is 5. And 90 divided by 15 is 6. So our answer is 5/6. So we have proved using algebra that adding 0.38 recurring to 0.4 recurring does in fact give us 5/6. Thank you so much for watching this Now Maths video. If this was helpful, please give the video a like. And if you would like to see more questions like this, please check out our in-depth video linked below. See you next time.